Hello friends, today we are going to talk about the Lan standards. Now the question arises why these standards are required. So we know that in a network we will be using a different devices or different components. We may call it as a node or printers or any other networking device which is manufactured by the different manufacturers. Now, whenever such kind of manufacturers are manufacturing such devices that need to be compatible with each other, and for that compatibility, they must agree on certain standards, and these standards are defined by the organizations called as a IEEE, and these IEEE standards are followed by each and every manufacturer, and the devices are manufactured so that whenever a device gets connected into a network, that device gets connected easily without any complexity, and that compatibility has been maintained because of these standards. So we need to understand these standards, how these standards will help different technologies or different topologies, different techniques that are used in computer networks, and how this will so this will be an overview of the standards. We are going to see it in next lecture or this lecture. So this lecture will be focusing on the standards and the Ethernet 802.3 and its performance, and in next lecture we'll be looking for the 802.4 and 802.5 type of standards. So 802 is the standard defined for the industry that will provide you the advantage of interoperability. It will provide you the advantage of low product cost, and easy to manage the standards. Now you can see the interoperability means the device which is manufactured by a Samsung and the device is manufactured by a Sony, both are compatible. That means if they gets replaced, your working will not hamper. So because of these standards, so if let us consider that Samsung decides to develop its own standard and Sony decides to develop its own standards. Now just think about it. If they decide to develop their own standards, what will be the cost of overall product? Obviously the cost will go high. But since the standards are common, which are developed by IEEE and that are used by the whole manufacturing community, because of that the cost has been reduced and it is easy to manage the standards. Since only one organization is taking care of maintaining the standards, it is easy to manage. So what are the common LANs that we have seen? We have seen the bus based LAN. In that we have gone through the techniques topologies like Ethernet, then the token bus, then the ring based LAN is there, then the token ring, and switch based LANs are there, switched Ethernet or ATM LANs are there. So our focus will be on Ethernet, token bus and token ring only. Okay, then we'll be discussing about this in detail as we proceed with the lecture. Now 802 standards define, basically it is defined for the two layers of OSI model, that is a physical layer and a data link layer. Again, data link layer is subdivided into two sub layers, that is medium access sublayer and logical link control sublayer. So we'll call it as a MAC sublayer and LLC sublayer subsequently. So this is how exactly the IEEE standards or 802 standard you can check for. Now here you can see that 802.2, which is associated with LLC. Oh, okay, 802.2 is associated with the LLC. you can see it at second layer, but 802.3, 802.4, 802.5 and 802.11 which is meant for Ethernet, token bus, token ring and wireless LANs are at physical layer. So these standards are defined at physical layer. So 802.3 which uses the CSMA CD type of communication to understand the exactly whether the collision has detected or not. So Ethernet uses CSMA CD technique. Token bus is using the token concept. Token ring is also using the token concept. It is an extended version of that one, but the standards defined for token bus and ring will be different. The buses are used in 802.3 and 802.4. So since it is at physical layer, so we need to understand exactly how exactly the cabling layer is, or how exactly the physical wires will help to identify the structure or to identify the networks, or the standards are defined accordingly. If the Ethernet is there, then the Ethernet on the basis of cable used or on the basis of speed, they are defined, and accordingly the wiring will change or the cable will change accordingly. So we'll see soon such kind of standards, because electrical parameters are defined at physical layer, and that depends on what kind of bandwidth you are expecting and what kind of speed you are expecting, and for that what type of wire you will be using or cable you will be using. So 802.3 all the protocols use the same address format, that is a 48-bit, and which is a globally unique address, so it gives you the information about first 24-bit will be, that is called as a OUI, that is organizationally unique identifier, and it is generally taken by, this is generally applicable to the manufacturers. So this identifier is taken by, or they have authority to take it from the standard authorities, that is IEEE. They will take it and they will register for the unique ID number for their own products. So that is called the organizational unique identifier. So, and the last 24 bits are set by the organization, that will be the MAC address for your particular device. So OUI, let us consider that for Sony Corporation, the OUI is 0019 and C5. Whenever you see any networking device, so in that networking device manufactured by Sony, the hardware address that is represented by 48-bit, it will be represented by first bit will be 0019. C5 will inform you that this bit is, or this device is manufactured by Sony Corporation. So this is this caret will be taken by IEEE 802 standard. Now there are different standards available in 802 category. So 802.1 it is used for interconnection bridging, 802.2 it is for LLC, it is 802.3 for Ethernet, that is CSMA CD LAN, 802.4 for token bus and 802.4 token ring LAN, 802.11 that is a wireless LAN, whatever may be the wireless technology you are using, that is defined under 802.11. So here you can see that from 1 to 22 there are so many standards are defined under 802, and 80 all the standards written in black are active presently, which are in blue which are inactive, and which are in red now these are disbanded, that means they are not in existence. So only we'll consider about the black, but for the sake of study purpose we'll be focusing on 802.5 also, so that you can understand. Now our focus will be on 802.3 Ethernet, which is meant with a CSMACD type of communication technique. Okay, they use the CSMACD. So CSMACD, that is a carrier send multiple access with a collision detection, was used to send the data over a shared link that may be a coaxial or that may be a twisted pair type of cable used to connect all the computers in the network. That means when you are putting it in a LAN, so it may be connected with a coaxial cable if it is a bus type of topology. Even if it is a star type of topology, then you can use the coaxial cable, but nowadays nobody uses it. So all of them you are using UTP cable. So UTP cable is also used. So CSMACD system is used to connect multiple personal computers on a single cable that is named as a Ethernet. So Ethernet or 802.3, that is IEEE 802.3 standard, only defines the MAC, that is a data link layer and physical layer of standard OSI model. So 802.3 is used for that one. Now wiring and cabling standards, as I said, that since 802.3 works at physical layer also, so for that purpose cabling type is also very important. So depending on what kind of cable you are using, then what type of cable you are using and its technical name, the capacity of your network will change accordingly, and there are certain advantages and disadvantages associated with that one. Now if you are using the 4 type of cabling that is used in 802.3, then you will be using 10 base 5. 10 base 5, this is what the cabling you are using. 10 base 2, 10 base T, 10 base F. Here 10 means this is the speed of your data. This is the speed of your data, that, or we will call it as a data rate. So that is a 10 Mbps, that means 10 megabits per second. And 5 means, 2 means, T means it has a certain significance. Now here we will see 10 base 5. 10 base 5 means 10 we have already seen, it is related with the data rate. Base 5 means this 5 will represent, it is a thick coaxial. It is a thick coaxial. The maximum length you can have 500 meters. The maximum number of nodes you can connect to such kind of network will be 100. The advantage is long cable length. Now 10 base 2, here you can see that 10 base 2. So 5 is greater than 2. That's why if 5 is the thick, 2 will be thin. So RG58, that is a thin coaxial cable, will be utilized. But the maximum length will be only 185 meters and you can only connect 30 nodes to a particular network. But the advantage is it is low cost. Now the next one is 100 base T. T means it is a twisted pair. So twisted pair, it may be a telephonic line, or there is a nowadays a specialized cable is utilized, that is a category cable with a unshielded twisted pair cable and with a category 3, 4, 5, 6. Nowadays 5 and 6 are in use, and these category cables, that is a twisted pair cables, are used. You can use it up to maximum 100 meters, but now you can see the number of devices are increased from 100 to 1024 and it is easy to maintain. So if one pair goes down, you can use the other pair which is in use. So for that purpose you can utilize this. And 10 base F, here you can see that F is for fiber optics, and the advantage is that you can go for a longer distance, that means up to 2 kilometers you can easily transmit the data, and the devices is also high, and obviously we know that the fiber optics, the noise interference is very less. So this is how the wiring or cabling standards are used or defined for 802.3. Now we know that at MAC layer data encapsulation and link management is done. So data encapsulation, we have already studied this frame format in data link layer chapter. So please refer to my videos related to that one so that you will understand the concept. Addressing and error detection, this can be done with the help of data encapsulation. So error detection and correction up to certain layer, that is the main function of data link layer. And link management with a CSMA/CD and backoff algorithm, that is done with the help of link management, and that is also a part of your data link layer. So 10BAS-T, as I said earlier, is the most popular method used, and this standard is also called as a standard Ethernet. 10BAS-T is also known as standard Ethernet, and it works on star topology. So you will be using a unshielded twisted pair, that is a UTP cable with RJ45 connector, and you will be getting maximum length of 100 meters and 1024 devices you can connect. So this is how the Ethernet frame look like. So you can see that there will be a preamble. Preamble trains the clock recovery that for use for synchronization. Then the SFD that will tell you this is the start of the frame. Then there is a destination address. So 48-bit unique address you will be putting here. That means hardware address you will be putting here. Then sender's address that you will be putting as the next one, that is SA. Then the type will indicate the protocol of encapsulated data. If you are using the IP address, then in that case you will be using 0x0800. That means if you are using IPv4 version 4, then in that case the IP will be represented like this, 0x0800. Then you need to pad it so that the proper frame length will be maintained. So you need to pad it with the zeros if the data is small. And cyclic redundancy check is for checking the bit errors in the frame. Okay, now we have already gone through this one. So if your physical address is there, then you will be maintaining the type 0, and if it is a multicast address, you are maintaining multicast in a sense broadcast, then you will be putting address as a 111. Okay, so this is what we have already seen. So data you can put maximum up to 1500 bytes. Now related to this, there is two important concepts if you want to measure the performance of Ethernet. Whenever the collision occurs, how exactly in CSMA/CD the system works, how exactly the system waits, and how the communication made successful, how the packet is delivered from the source to destination even if the collision occurs. So for that purpose we should know the Ethernet backoff algorithm, and that backoff algorithm works on the binary exponential backoff algorithm, it is also known as. And initially you choose a random slot of 2 raised to k, and k is the number of collisions that the frame has suffered. Then the contention slot we have already seen. Such kind of concept we have already gone through the previous lectures, so please refer to my previous lectures. So 2 into end-to-end propagation delay, that means from one end to other end, what will be the propagation delay, that contention slot you need to keep into existence, and this algorithm will be adopted with a changing network load. If the load is changing, obviously this algorithm is changing its k value. So A and D, you can see that here you can understand how exactly it is working. Here it is A and here it is B. So that it has a distance of 7.5. Okay, it has a distance of 7.5. That is a propagation delay between these two terminals. So 2 into propagation delay is nothing but you will be getting a 50 microsecond is the slot length. 50 microsecond is the slot length. Now when you start with a t equal to 0 microsecond, and it is assumed that A and B collides, so Ka is equal to Kb is equal to 1 is what we have considered. Now choose the randomly. Now here it is 1, only one collision is there, so K k is selected as 1, so 2 raised to 1 is equal to only 2 values will be there, so you choose any value between the range of 0 and 1. So A chooses 1 and B also chooses 1. So for 15 microsecond it will check for that one. Now at 30 microsecond, now it will go for a double. Again A and B collide, so it goes to 2. So 2 raised to 2, between 0 and 3 you choose anything. So let us consider that A chooses 2 and B chooses 0. So what happens? Because of that, at t equal to 40 microsecond, B transmits it successfully because B had chosen 0 and A had chosen 2. So at 75 microsecond, A will transmit it successfully. So the slot is changed. The slot 0 will be taken by B and slot A will take the second slot, that is the third slot. So accordingly, at 75 microsecond A will transmit successfully and at 45 microsecond B will transmit it successfully. So this is how the binary exponential backoff algorithm will work. Again at a particular moment, if the collision occurs, then Ka and Kb equal to 3, then 2 raised to 3, between 0 and 7 the slot will be chosen and accordingly transmission will take place. So this is how the binary exponential will work. Okay. So after every 50 microsecond it will try to attempt, and maximum 15 attempts it will make, and at 16th if the 16th backoff occurs, the transmission will be considered as a failure. Okay. Now to understand what exactly how the Ethernet is performing, there are certain points we need to understand. So the Metcalfe and Boggs, they studied it, how exactly you will understand or evaluate the performance of 802.3 under various loading conditions, that is a full load and constant load. So for that purpose they ignored the binary exponential backoff algorithm and they considered that only probability P will be utilized for a retransmission, and it is considered that the station A acquires a slot. One station is acquiring a slot A, then how A will be acquiring this slot? So A will acquire that slot. A is equal to K into P into 1 minus P raised to K minus 1, where K is the number of stations ready to transmit. If there are 5 stations, then we'll consider that out of 5, 3 are ready to transmit the stations. So 3 into P, that is a probability that you will be deciding that all the stations are retransmitted. So that probability you have to calculate it, and A will be the maximum, that a particular station will get that slot. That probability becomes maximum only when P becomes nearly equal to 1 by K. So as P becomes 1 by K, A becomes nearly equal to 1 by E. Okay. So as K tends to infinity. Okay. K is maximized only when P is 1 upon K, and A tends to 1 upon E when K tends to infinity. Okay. So this is how you are going to calculate. So they have proposed the formula A into A minus 1 raised to J minus 1 is the probability that the contention window of jth slot, then the mean number of slots per contention they have calculated it, and that is calculated is equal to 1 upon A. So each slot is bounded by time 2t, so that they have come up with a window size W. So that window size is given by W is equal to 2 into tau into E, that is nearly equal to 5.4 tau. So the performance they have calculated, that is the channel efficiency they have calculated with the probability P, that is the transmission time per frame. So channel efficiency is equal to P divided by P plus 2 tau divided by A. Again, the channel efficiency they have defined in terms of various parameters such as frame length, bandwidth, cable length, speed of the light. So they have calculated P is equal to F upon B, that is nothing but frame length divided by bandwidth is equal to mean transmission time per frame. So channel efficiency, again if I replace this value into this one previous equation, the channel efficiency I'll get equal to 1 upon 1 plus 2B LE divided by CF. Okay, so as the bandwidth and cable length increases, that means bandwidth is increasing and cable length is also increases, so this will decrease the efficiency. This is how they have measured the performance of 802.3, and they have come up with this channel. So number of frames you go on increasing, and number of stations also you add it, then you will say that the channel efficiency is decreasing, and after substantial time it remains same. Okay, it is constant one. So